Okay, let's dive right in. The plan we're talking about today is so big, so ambitious, it honestly sounds like something straight out of science fiction. Building a completely self-sustaining city on Mars by the year 2050. And look, this isn't just about planting a flag and setting up a small research outpost. We are talking about humanity's next great construction project, a second home. So the real question is, how in the world do you even begin to build a city on another planet? To really get your head around the sheer scale of this challenge, you just have to look at the travel time. A trip to the moon, that's kind of like a long weekend trip, right? It takes about a day. If you forget something, you can get another shipment from Earth pretty quick. But Mars? Mars is a completely different beast. We're talking an 8-month journey, one way. That isn't a commute, that's a full-on migration. And that single fact, that massive distance, changes absolutely everything. And that's exactly why the goal has to be this ambitious. When you're that far away, you can't just call home for a resupply mission. The Martian city has to be 100% self-sufficient, able to support 1 million people all on its own. The whole point is to build a city that could keep going even if, for some reason, the ships from Earth just stopped coming. So where do you possibly start with a project this huge? Well, you don't start with people, you start with robots. Long before the first human boot ever kicks up that red dust, Mars is going to be a planet of machines set ahead to get everything ready. And let's get into why that's not just a good idea, but an absolute necessity. Because make no mistake, Mars is one of the most hostile places we've ever even dreamed of going. I mean, we're talking about a place that's colder than Antarctica and drier than the Sahara Desert. The atmosphere is so incredibly thin that if you poured out a cup of water, it would just instantly boil away into space. And on top of all that, with no magnetic shield to protect it, the surface gets blasted with deadly solar radiation, 24/7. This is no place to drop off a construction crew and just say, "Good luck, guys." Which is exactly why the first inhabitants won't be human at all. They'll be these, Tesla's Optimus robots. And, it's probably not a coincidence that a sister company to SpaceX happens to be developing the perfect AI-powered humanoid robot you'd need to start building on another planet. These bots are designed to do just about any job a human can, which makes them the perfect robotic pioneers for this new frontier. So the plan is to roll this out in waves. The first one could launch as early as 2026, just 5 Starships, each carrying a pretty light load, about 10 tons of cargo. And the main goal of that first mission is brutally simple: just land in one piece. SpaceX has this philosophy of learning by doing, which often means, well, things blow up. But once they figure that part out, maybe by 2028, then the real fleet arrives, 20 Starships, this time packed to the gills with 75 tons of infrastructure. So what is the #1 mission for this robotic vanguard? It's to build a functioning outpost from the ground up. They have to get the absolute essentials. We're talking power, fuel, and basic facilities up and running before the first humans even begin their 8-month trip from Earth. The spot they've picked out for this is a region called Arcadia. And there's one simple reason why. It's believed to have huge underground deposits of water ice. On Mars, water isn't just a resource, it is the resource. It is, without a doubt, the master key to everything, the absolute foundation for the entire colony. Now, this is where it gets really interesting, because water isn't just one resource, it's actually 3. Of course, you can melt it for drinking water, but if you run an electric current through it, a process called electrolysis, you can split H2O into its basic parts. That gives you breathable oxygen for the human settlers, and it gives you hydrogen. And that hydrogen is the key ingredient for making rocket fuel right there on Mars. This whole concept is a total game changer, and it's brilliant. The robots will literally pull carbon dioxide out of the thin Martian air, combine it with the hydrogen they got from the water, and just like that, you have methane. That's the fuel that powers the Starship. This little chemical trick is what makes a return trip to Earth possible at all. So how are they going to get to all that underground ice? Well, here's another one of those, let's call them happy coincidences. Technology from the Boring Company, another Musk company, is going to be adapted and scaled down to create Martian mining rigs. These are the machines that will dig up the raw materials that make everything else work. And this is a perfect example of the mindset you have to have on Mars. Use everything. Nothing goes to waste. Even a leftover dirt and rocks from the mining operations get a job. They can be processed into a kind of asphalt, which is perfect for building the first landing pads and roads for all the ships that are coming later. Okay, so let's recap. The robots have landed, they're busy mining ice, they're making oxygen, they're brewing rocket fuel. The basic infrastructure is taking shape. And now the game changes completely. It's time for the first humans to arrive. So remember the cargo capacity for those first few robotic missions? It was about 10 tons per ship, just enough to carry a few bots and their basic gear. Now look at this leap. To support human life, each and every Starship needs to carry 150 tons of cargo. That is a 15-fold increase. It's an incredible visual that just shows you how much more resource-hungry and, well, needy humans are compared to robots. And bringing people introduces a brand new, massive challenge: power. The robots could probably get by with just enough solar energy to recharge their batteries, but human life support systems, things like heating, air pressure, water recycling, they need a constant, reliable, and absolutely huge supply of energy, 24 hours a Martian day. The solution is a classic solar plus storage setup. A big solar farm will generate all the power during the day. And then, to survive the long 12-hour Martian night, the colony will draw its power from massive batteries. And yes, you guessed it, another convenient piece of synergy. They'll be using Tesla megapacks, the same kind of industrial batteries we use to power small towns right here on Earth. So where do these first Martian pioneers actually live? The initial plan is incredibly clever and super efficient. They'll just live in the same starships that brought them there. The landers themselves are going to be repurposed as the very first Martian habitats. Now, they're not a perfect long-term home. They're basically just tall metal cylinders, but they provide immediate, life-saving shelter right out of the box. All right, this is where we get to the truly mind-bending part of the whole plan. To ever become self-sustaining, the colonists can't just live on Mars. They have to live from Mars. And that means learning how to use local materials for absolutely everything, from the walls of their homes to the food they eat. Which brings us to a huge question. How do you build permanent homes that can shield you from radiation on a planet where you can't just ship over a load of lumber and steel? You have to make your own building materials, from scratch, using only what you can find around you. The answer they've come up with is a material that sounds, well, a little gross, but is absolutely genius: biocrete. It's made by mixing Martian soil, which is called regolith, with a special binding agent. That agent is urea, a compound that is filtered directly from human urine. And the wildest part of all this? The resulting biocrete is actually stronger than the concrete we use right here on Earth. So we've got a plan for fuel, for oxygen, for water, power, and even shelter. But there is one last hurdle, one final piece of the puzzle for true self-sufficiency, and it just might be the toughest one of all. And that final problem is food. You see, you can't just stick a potato in Martian soil and expect it to grow. The ground there is toxic. It's filled with chlorine-based compounds called perchlorates that are lethal to plants. So the solution is a two-step process. First, you need an industrial process to basically wash the toxins out of the soil. And then, to make that now sterile soil fertile, well, if urine is the key to Martian concrete, then human solid waste is the key to Martian fertilizer. It is the ultimate closed-loop system. So when you lay it all out, from robotic pioneers and self-fueling rackets to buildings made from urine and farms fertilized by human waste, there's a technical roadmap. The engineering and the chemistry challenges, as monumental as they are, actually seem to be solvable, which leaves us with a final and far more human question. We have a detailed plan for how to build a city on Mars. The real question is, who will be the